तो हमारे पास है क्वेश्चन नंबर 13.6 एंड द क्वेश्चन सेज कि सपोज वी थिंक ऑफ अ फ्यूजन ऑफ अ F56 nuclei into two equal fragments Al28. Is the fusion energetically possible? Argue by working out Q for the process given M of iron 56, mass of nucleus of iron 56 is 55.93494 atomic mass unit, and mass of nucleus is 27.98191 AMU, right? So for checking the feasibility, we know that suppose we have a initial mass of suppose by seeing this reaction. So this is a nucleus, this is an atom of Fe, right? And this has a nucleus, right? And if the mass of this nucleus, if the mass of this Fe nucleus is going to be greater than mass of this two constituents nucleus, Al2 into 2, that means if this is greater, that means कि some amount of mass it get converted into binding energy and released, right? If this mass is less, if the sum of both Al2 nuclei mass is going to be less than Fe mass, that means some amount of mass is get converted into energy and released for forming more stable compound. But that is not the case. If this mass of Fe is going to be lesser than the summation of the mass of this two elements or atom, that means this will going the product that is going to be formed is more unstable, because this is taking more mass here, and that is not liberating the mass for binding energy. So that's why it is the case. So you can you can see this process by this example. Suppose C plus O2 gives CO2, right, and liberates heat, right? But if we want CO2 gives C plus O2, we have to give amount of energy for it, for getting this is an stable compound, this is a stable compound because energy is released. But if we want to convert CO2 into C plus O2, that is an unstable compound relative to this, right? So we have to give heat, and that is possible theoretically, but in real life it is not possible. By giving heat you can't break this into C plus O2, right? Because this is very unstable and energetically it is not feasible, right? So by this way you can understand this. If the mass of Fe is going to be less than the mass of these two constituents nucleus, that means that binding energy is needed, not released, right? So we are going to be get an unstable compound here, unstable nuclei here, right? So I hope you have understand this. Now let's solve the question we have. So question says that we have a reaction here, and all the masses of the nuclei is given. So for solving this you have to rely on the Q value. If the Q value you get is greater than 0, that means energy is released, and that means a stable compound. If Q value is less, that means it is endothermic and that is forming unstable compound, right? So let's solve, and let's see how you have to write this if this questions came in your exam. So first of all, given that here it is given that in your question you can see that mass of nuclei of Fe and mass of nucleus of Al2, Al, right? So that is given and the reaction is given. You have to say that it is feasible or not, right? So as we know that the Q value is mass initial mass of nucleus initial minus mass of nucleus final into C square, right? If this greater than 0, then exothermic means a stable compound. If it is less than 0, then unstable compound and energetically not feasible, right? So for calculation we need mass initial and mass final, that is given in the question, right? So you can get that, and you have to put the mass initial then mass final, and you have to subtract that. You can see that you are getting the value of Q in negative. That means the Q is needed, the energy is needed, and because the energy is needed, that means it is endothermic and unstable compound and energetically not feasible, right? As same as the example of CO2 gives CO plus O2, that is not feasible. It is written, it is, you can see it written, but it is not feasible in real life, right? So this is the thing.